Assalamu alaikum warahmatullahi wabarakatuh. My dear students, as you all know that we are done with our syllabus as far as mathematics is concerned. But what we are going to be doing throughout this holiday is to be selecting some few topics that I know you are having difficulties and try to solve one or two examples on those topics. And number one, we want to look at applications, some application of differential calculus for today. And under the subtopic, we have the gradient to the curve. How can we use calculus, differential calculus, to find the gradient to the curve? And as you know, that when you are given a curve and you have to find the gradient to that curve, what you need to do is that you differentiate that curve once, just once. And the example is what we have here. Don't forget, you have done differentiation of polynomials, you have done differentiation using product rule, using quotient rule, implicit differentiation, and all those things. Then we even did chain rule. So we want to look at some application of differential calculus, and that is gradient to the curve. We are given example 1. Find the gradient of the curve y is equal to x cubed minus 4x squared plus 2. So the next thing is to differentiate our dy all over dx, which is the same thing as slope or the gradient, is equal to differentiate this x cubed, you have 3 times x, then raised to power 3 minus 1, and that is 3x raised to power 2, then minus 2 times 4 x raised to power 2 minus 1, and that is 8x. Then you know that the derivative of the constant is what? 0. So the differentiation of, if you differentiate 2, you are having 0, so we don't need to write that. So that means that our m is equal to 3x squared minus 8x. Then we are told that the point on those curves is minus 1 and minus 3, which means our x is minus 1, our y is what? Minus 3. So we now see at x equal to minus 1, then our gradient is equal to 3, open the bracket, minus 1 squared, minus 8, open the bracket, minus 1. So you now have 3 into bracket 1, because by the time you square minus 1, you have 1. Then plus, minus 8 times minus 1 will give you plus 8, and that is 11. Which means that the gradient of this curve at this point is what? Is 11. So, example 2. Example 2, it is possible that you are given the gradient and you have to find the point, and the example 2 will take care of that. We are told that we should find the gradient, find the point on the curve. On the curve, y is equal to 2x raised to power 3 plus 3x squared minus 12x minus 5, where the gradient is 0. This one, we have been given the gradient. We are now asked to find the point on those gradients. That is, we are asked to find the point on the curve. Y is equal to 2x raised to power 3 plus 3x squared minus 12x minus 5, where the gradient is 0. So, solution, we know that our dy dx is the gradient. That means that we are given y is equal to 2x raised to power 3 plus 3x squared minus 12x minus 5. Then dy all over the x is equal to this multiplied by this raised to power 3 minus 1, and that is what? 6x raised to power 2. Then plus this and this raised to power 2 minus 1, it will be what? 6x. Then minus 12. The derivative of a constant, I've told you that is 0. Because when you have 5x, is same thing, when you have 5, same thing as 5x raised to power 0. And by the time you differentiate, you have 0 times 5 raised to power x raised to power 0 minus 1, and that will give you, everything will be 0. So the derivative of a constant is 0. So this is what we have. Yeah. So that means that now, but mind you, we have been given the gradient from the question. Our gradient is 0, but the y, the x, which is equal to the m, the gradient, is equal to 0. So that means that 6x squared plus 6x minus 12 is equal to 0. So by the time you divide through by 6, for some reason, this is a quadratic equation that you can use any method, either factorization method, completing the square method, or the use of general formula. But the best thing for you to do is to simplify it further. That is, we divide through by 6, so that the expression can become simpler, so that you can easily solve it. Divide through by 6. So if you do that, you have 6x squared all over 6 plus 6x all over 6 minus 12 all over 6 is equal to 0 all over 6. So this and this will go. You have x squared. This and this will also go. You have plus x. Then this one will be minus 2 is equal to 0. So I'm going to use factorization method because that is the simplest method. Any method you decide to use at this point, you are very correct. Either you use completing the square method, or you use quadratic formula method, use of general formula, or you use factorization method. But factorization method is very simple and it will not waste your time. So I'm going to use factorization method. In factorization method, you are going to think of two numbers. Which one you had? You are going to have 1 because the coefficient of x here is 1. And when you multiply it, you are going to have minus 2 because the coefficient of x squared here is 1 multiplied by minus 2. That is what? Minus 2. So you think of the number. So the number are plus 2 and minus 1. So we can now say x squared plus 2x minus 2 is equal to 0 because plus 2 minus x will give you x. So we have not made any changes. It's still correct. So x and x is common to both sides. I can bring one x out. If I bring one x out, I'm left with x plus 2. Here also minus is common. I can factor minus 1 out. I have x plus 2 is equal to 0. So if you open the bracket, this time this is 3x squared, this time this is 3 plus 2x, this time this is 6 minus x, this time this is 3 minus 2 is equal to 0. So from this, we now are going to have x minus 1 and x plus 2 is equal to 0. Therefore, our x minus 1 is equal to 0 or x plus 2 is equal to 0. Because when you have two expressions, let's say you have x multiplied by y and they say it's equal to 0. It's either this is equal to 0 or this is equal to 0. So that is the equation. All the two of them are 0. And that's what we have here. And from this, our x is equal to 1. We transfer minus 1 to the other side, x will be equal to 1. Or x is equal to minus 2. So we have gotten the value of x, the 2 points for x. What we need to get our complete coordinate, we need to find the value of y at those points. But remember that y has been given from the question to be what? 2x raised to the power 3, that's 2x raised to the power 3 plus 3x squared minus 12x minus 5. That means that y is equal to 2 into bracket 1 raised to the power 3 plus 3 into bracket 1 squared minus 12 into bracket 1, then minus 5. So this is now equal to what? 2 into bracket 1 plus 3 into bracket 1 minus 12 minus 5. So this is equal to 5 minus 12 minus 5. So this and this will go. Then that means our y is equal to what? Our y is equal to what? Minus 12. Also, so it means we have the point x and y. Our x1, our y1 is equal to minus 12. So our x is what? When x is 1, y was what? Minus 12. Also, when x is equal to minus 2, y will be equal to 2, open the bracket, minus 2 raised to the power 3 plus 3 into bracket minus 2 all square, then minus 12 into bracket minus 2, then minus 5. So by the time you open the bracket, what we are going to have is, now look at this. You cube this one, you have minus 8. Minus 8 times 2, you have minus 16. So y is equal to minus 16. Here also, By the time you square it, you have 4 times 2 times 3, that is 12. So you have 12. Then here you have minus 4 minus 12, then minus 2. By the time you multiply, you have plus 24. So plus 24, then what? Minus 5. So this is equal to this one, and this will give you minus 4. And this is 20. So, and that is what? 15. So we have 15. So hence, our x2, y2, the coordinate, the second coordinate is equal to, that is, when x is equal to minus 2, y is equal to 15. So those are the coordinates of those points. Now, that is that when you are using differential calculus to obtain the gradient, or you are given the gradients to the curve, and you are asked to obtain the points of those curves. Another application of the differential calculus is the use of differential calculus to obtain the velocity and acceleration of a body. The use of differential calculus to obtain the velocity and acceleration of the body, or the use of differential calculus to obtain the equation of the tangent and the equation of the normal to a given curve. So that is the second subtopic that we are going to look at. That is tangent and normal to a curve. So example 1 is here. We are told to find the equation of tangent and normal to the curve. So we are given the curve, we have to find the equation of the line, and the curve is y is equal to 2x squared minus 3x minus 5 at 2 and minus 3, meaning that at the point where x is equal to 2 and y is equal to minus 3. So if you want to apply this, you want to obtain the equation of the tangent first. What you need to do is that we are given y to be equal to 2x squared minus 3x minus 5. We need to find the gradient of the tangent, and that is the y all over the x, and this is equal to 4x minus 3. Because by the time you measure the constant, you have 0. By the time you measure this, because 3x is then that 3x raised to power 1, and that means 1 times 3 will be 3 raised to power what? 1 times 3, then x raised to power 1 minus 1, and that will be 1 times 3 x raised to power 0. And that will be 1 times 3 into bracket 1, which is equal to 3. And that's why we got 3 here. So, at x equal to 2, that means that our m, which is equal to dy all over dx, let's call this m1. Here m1 is the gradient of the what? Of the tangent. Is equal to 4, open the bracket, 2 minus 3. And that is what? 8 minus 3, which is equal to 5. That means the gradient of the what? Of the tangent is 5. Don't forget, the equation of the tangent says that we have y minus y1 is equal to m into bracket x minus x1, where m is what? The gradient of the tangent. So we have y minus, our y1 from this question is what? Is minus 3. So we have minus 3 is equal to, our m is what? Our m1 is the gradient of the what? Tangent, which is 5. Open the bracket, x minus x1. Our x1 is 2. So by the time you open the bracket, you have y plus 3, because minus times minus will be plus, is equal to 5x minus 10. So if you like, and leave your answer like that, but it is better you transfer everything to the other side so that it will be equal to 0. The right hand side will be equal to 0. That is the best way of writing the equation. So that means that we have y plus 3 minus 5x plus 10 is equal to 0. That means we have y minus 5x plus 13 is equal to 0. That is the equation of the tangent. So the next thing is to obtain the equation of the normal. You have to recall that what? M1 multiplied by M2 is equal to minus 1, where M1 is what? Gradient of the tangent, and M2 is what? Gradient of the normal to the given curve. Normal. So we need to find the gradient of the normal now using that mathematical expression. We know that our M1 is 5 from this, so we are going to substitute 5 times M2 will be equal to minus 1. So we are going to divide both sides by 5. That means M2 will be equal to minus 1 over 5. So that will now be the gradient of the normal. So, but M1, what is the gradient of the tangent, is what? 5. And that means 5, and we know that M1, M2 is equal to minus 1. That means 5M2 is equal to minus 1. That means M2 is equal to what? Minus 1 all over 5. By the time you divide both sides by 5, I think you are in the highest class as far as O level is concerned. So you don't need to be telling to divide both sides by anything. So now, the next thing to do is that to get the equation of the number, we recall that what? Y minus y1 is equal to M2, open the bracket, x minus x1, where M2 is the gradient of the what? Of the normal. So we have y minus, our y1 was minus 3, is equal to m, which is minus 1 over 5, open the bracket, x minus 2, because you have been given from the question, from the same question. Then the next thing is to open the bracket, we have y plus 3 is equal to minus x over 5, then plus 2 all over 5. So for simplicity, I can multiply everything by 5, that is, multiply through by 5. If I do that, I will have 5y plus what? Plus 15 is equal to, if you multiply this by 5, 5 you cancel 5, you have minus x. Multiply this by 5, 5 you cancel 5, you have plus 2. So by the time you collect that time, you have 5y plus x, then what? Plus 13 is equal to 0. This is the equation of the normal to recall. So we have successfully gotten our equation of the tangent and equation of the normal to recall. So the next thing now is to give you a very little assignment. However, the assignment will still be written on the portal for you in case you are not able to write this as quickly as possible, inshallah. And the assignment, the first question on the assignment will say, it goes thus: find the gradient of the following. That's question 1. Find the gradient of the following curve at the point specified. And A, we have y is equal to x squared minus 3 at x equal to 1. Then B, y is equal to 2x squared minus 11x plus 12 at x equal to 2. So let me quickly write these two questions as your assignment. So yes, find the gradient of the following curve at the point specified. A, y is equal to x squared minus 3 at x equal to 1. At x equal to 1. B, y is equal to 2x squared minus 11x plus 12 at x equal to 5. Then question 2 said, find the equation of the tangent and normal to the curve y is equal to x squared minus 5x minus 8 at x equal to 4 and y is equal to minus 12. So that is your assignment. Find the gradient of the following curve at the points specified. A, y is equal to x squared minus 3 at x equal to 1. B, y is equal to 2x squared minus 11x plus 12 at x equal to 5. Then question 2 said find the equation of the tangent and normal to the curve y is equal to x squared minus 5x minus 8 at x equal to 4 and y is equal to minus 12. Inshallah, we meet on Monday by the special grace of Almighty Allah.